we're starting vector algebra before starting physics, because all derivation is always vectorial approach. We prefer only vectorial approach because it is very easy, and for this we group for basically calculus, trigonometry, algebra and coordinates. We first of all command on these subjects, and to improving physics, these are the basic mathematics which we must vector. We start from vector. First definition: vector is a quantity having magnitude as well as a direction, and it obey triangle law of addition. It obey triangle law of addition is the basic. What is the vector law of triangle addition? This we further discuss. Vector can be represented by an arrow, like a symbol above. Its length is chosen to proportional to the vector, and its direction is taken in the sense of vector quantity. Okay. Vector can be added to vector, not a scalar. So vector addition means vector of at least two vector addition. Basically we add vector by triangle law. Vector of the same kind can be only added, that is electric field can be added to electric field, force to force, acceleration to acceleration, but velocity cannot be acceleration to vector cannot be added to acceleration, or acceleration cannot be added to force. This is the basic. Now vector is represented as alphabetical symbols, generally in a small letter like A, and V, a symbol arrow give up on its head. In books it is boldly represented, and vector, this is a vector A, and its magnitude is denoted as symbol like this, and this is the modulus, or are represented as simply A, not in bold letter. This is vector represented by an arrow means if we take a vector, take a vector A as 2 meters per second, and we take another vector B is supposed to be 4 meter per second. These two representations are wrong because A is a vector, but here the right side of these two vectors are only magnitude. So it must be a direction to the right. So it is any direction. Suppose direction like this, east or west, north, south, any direction. Yeah, direction in any sense. It is also direction. Sun maybe in same sense as in this or not. But these are the good and perfect representation. We do not represent a vector A. If we write this as, it is wrong, like this, A. If we write a vector A, if, it is a magnitude, we prefer only like this, it is a magnitude. And if we represent right side, we write 2 meter per second direction, suppose east. It is wrong. It is wrong. It is wrong. This is a magnitude, so not right side. We taking a direction. So it is the good representation. It is wrong. These are representation. Now, what is the meaning of vector can be represented? Choosing the proportional to the vector quantity at its and its direction in the sense of vector quantity. Vector can be represented by an arrow and its length chosen to proportional to A, means the arrow length can be depend on your choice, but it is proportional to vector. That is, if we represent a vector A, vector A like this, vector A in any direction, vector A. Suppose it is a vector A. So vector A. And we take a vector B. If we take a vector B, suppose in the same sense, then its length is doubled of vector A because here vector A is 2 meter per second and V is a 4 meter per second. So magnitude of vector B is doubled of this. So its length A is half of, or the vector B has length doubled of this. It is not a double, but we suppose it is a double. If you confuse, so we take another examples, another represented like this. Suppose vector A is this. We reference taking here for east and north only, at least two representation, symbol arrow east and north, then remaining are automatically south, it is west. A is in the sense of east. If its length is 1 centimeter, means this is called a geometrical length, and it is which has a magnitude of A, it is called a physical length. Symmetrical length, it is a physical length. So physical length is proportional to geometrical length, or reverse we say symmetrical length actually taking here 1 centimeter proportional to this physical length. If we taking 1 centimeter and suppose a vector B is directed having same magnitude meter per second, but suppose directed north. So vector B is directed as a north. So and of supposed to be doubled off, that is it is an arrow in this direction, north direction. So vector B is 2 centimeter of length, geometrical length. This is the geometrical length, it is the physical length. This is the meaning of proportional to the vector, means this is the length of arrow of vector A, this is the length of vector arrow vector B. So if we taking 2 meters per second and its magnitude doubled of this, so its length is doubled of this length. It is 1 centimeter, then it is a 2 centimeter. It is a vector B. Okay, this is, and also here A and B are of the same kind, because this is also a velocity and this is also, but maybe a direction. Vector, another thing is that if we're taking a vector A, of 2 meters per second and directed in the east, and B or another vector, suppose C, taking a vector 2 meters per second in north. These two vectors are called not equal vector because not equal vector, because these two vectors having same magnitude but not a same direction. That is our I'm saying actually if any of means magnitude or direction can change, vector will change. If we see here, but we say here magnitude of vector and are same. Dimension of also a vector quantity is same. Dimensionally equal. Sorry, it is not a B. It is actually C. Just C. Dimension of are same, and this is the L. This is the same. That is vector A and C are dimensionally equal, magnitude wise equal, but vector are not equal. Actually we are clearing that vector is changing if either of the magnitude or direction are changing. Okay, I hope it is clear. it is very long time, so take it.